हेलो गुड मॉर्निंग माय डियर स्टूडेंट्स। वेलकम टू डिजिटल क्लासेस। समय 10 से 12 वाला हर घर बने पाठशाला। दिस इज योर केमिस्ट्री पीरियड क्लास +2। एज यूजुअल वी आर डूइंग our unit 2 solution. So in this particular video I am going to recap whatever we have done last week before going to start today's topic. So let's start the recap of unit 2, that is solution. So solution, this word already you know. What is the meaning of solution? What is the definition of solution? It is the homogeneous mixture of two or more substances in which solute plus solvent is called solution. The solution is a homogeneous mixture of two or more substances. It is a binary mixture in which any one of the component is solute and other component is solvent, in which solute is that component which is present in smaller quantity and solvent is present in larger quantity. So in this chapter basically 3 topics we have finished. So one by one we will recap that. First topic was introduction of solution, in which we did definition, characteristics and classification of solution, and basically types of solution we did, in which solid solution, liquid solution and gaseous solution we discussed, in which solid solid, solid liquid, solid gas, liquid solid, liquid liquid, liquid gas, gas solid, gas liquid, gas we did. And then after that we did expressing of concentration of solution, in which percentage, mass percentage, volume percent, mass volume percentage, mole fraction, part per million, molarity we did, and some numerical related to this concept we did. Hope so you understood and you have practiced very well. So after that second topic was solubility. Once you know about the solution, then we are discussing about the solubility, in which the definition of solubility we did, dependence of solubility, in which nature of solute, nature of solvent, temperature, pressure are the dependency of solubility. Type of solubility we did, type of solubility 2 types, solid in liquid and liquid in liquid, and some terms related to solubility, in which dissolution, crystallization, saturation, unsaturation, these all things we did in last week. And in liquid especially we are discussing about the Henry's law, which is very important, in which we discussed about the partial pressure of gas. Partial pressure of gas in vapor phase is proportional to the mole fraction. It means that the Henry's law told us about the relationship between vapor pressure or the partial pressure with the mole fraction, in which partial pressure is denoted with P, mole fraction is denoted with X. So the relation between P is directly proportional to X. Okay, and in which P is equal to KH into X, and KH is Henry's constant. Under Henry's law, we discussed the significance of Henry, application of Henry, and limitation of Henry's also. These are theoretical topics. So if you are not remembering, so then please go through the last videos and watch the previous videos also. Okay. In the same series, the third topics we started, that is vapor pressure of liquid solution, which is very, very important. In which, what is vapor pressure? First, let's understand vapor pressure. Dear students, in a closed container, when we are going to boil a liquid, when we are going to increase the temperature of liquid is converting into vapor. You know very well. This is called evaporation. And when in a closed container, the amount of vapor is increasing, one stage will come when this vapor is going to be increase the pressure on the surface of liquid. So it means that amount of vapor is equal to amount of liquid will create the one pressure on the surface. That pressure is called vapor pressure. So the definition is pressure exerted by vapor molecule on the surface of liquid. Pressure exerted by vapor molecule on the surface of liquid at equilibrium is known as vapor pressure. So there are two types of liquid we have discussed, liquid in liquid and solid in liquid. In which liquid in liquid, vapor pressure of liquid in liquid is present, in which the solute is volatile, as liquid is one of the volatile component. And in case of solid in liquid, there is solute is always non-volatile. So under liquid in liquid, especially we will discuss the one more law, as Henry's law we have discussed under partial pressure. The vapor pressure, under vapor pressure we will discuss the Raoult's law. This is the main difference. Here partial pressure, here vapor pressure. Okay. So Francis Martin Raoult's in 1886, he has given this equation, in which P is equal to P1 naught plus P2 naught minus P1 naught, in which P1 naught is the solute and the partial pressure of solute, and P2 naught is the partial pressure of solvent. Okay, whole bracket x2. So this relation we have derived. So once again, if you have not understood, to kindly revise this topic from the previous video. So in the liquid in liquid, what we have discussed, what the Raoult's law states. Raoult's law states that at a given temperature for a solution of volatile liquid. Now we are talking about volatile liquid solute. So for a solution of volatile liquid, the partial vapor pressure, now here vapor pressure we are using instead of pressure. In Henry's law we discussed only pressure, here we are discussing vapor pressure. So partial vapor pressure of each component of solution is directly proportional to the mole fraction. So it is also same like Henry's law. In case of Henry's law, where we discussed about the P is directly proportional to X, here in Raoult's law we discussed about the vapor pressure is directly proportional to mole fraction. Okay. So in liquid there are two types of solution. One is ideal solution, second is non-ideal solution. Where ideal solution is what? Those all solution which obey Rolle's law, which have delta H is equal to 0, which have delta B is equal to 0, known as ideal solution. And non-ideal solution which doesn't obey Rolle's law and which have delta H not equal to 0, delta B not equal to 0. Okay, so in which differentiation way we can do all the molecular interaction in which A, B, solute, solvent, which is solution is equal to the pure solute or pure solvent interaction. Okay, for example, these are the following example we discussed in the last video also, where in case of non-ideal solution, AB, the interaction of solution is weaker than pure solvent and pure solute. Delta H is positive, delta V is positive in case of positive deviation, and example we have discussed in the last way. And negative deviation, as non-ideal is of two type, positive deviation, negative deviation. In the graph form we have discussed last way, in which interaction of molecule is greater than pure solute and pure solvent. Delta H is negative here, delta B is negative here. The reaction is the exothermic. Some of the examples are there. And one more relation is there, the azeotrope. Azeotrope are all those solutions, all those binary solutions are known as azeotrope, in which after boiling point the ratio of component is not changing, it is remaining same. The composition of the solution is remaining same in liquid as well as in gaseous phase. That is called azeotrope. So there are two types of azeotrope. Minimum azeotrope is actually exactly like the positive deviation, and maximum boiling azeotrope is showing like the negative deviation. So all these properties are the property of maximum boiling azeotrope also. All these properties are the properties of minimum boiling azeotrope. So dear student, this is all about what we did last week. Now in next video I will show you today's topic, that is the colligative property. So till then wait and kindly see the next video also. Thank you.